Welcome back here to Trig Talk. Today we're talking about answers from yesterday's homework assignment. Up here on the board, and I'm going to scroll down so you can see all of the evens, because of course your odds are in your book. So you can double check this. Who's ever subbing, you could probably just pause this for a few minutes while people just check their work. I will go through a couple of a couple of problems that I would imagine that you might have a couple of issues with. And then after that, we'll do a couple of trig identity examples, and then you, the viewer, will have some time to work on the next assignment for class for Wednesday. So, I would press pause right now. No, now. Oh, thank you. Hi, welcome back. So, two problems to try to do. These, again, are problems that you had on homework. I thought these would be problems that you probably have questions upon. So I thought, hey, I, being the kind, benevolent dictator that I am going to go through and we can set these things up. So, notice I've got something squared minus something squared. Now, the somethings that I'm squaring look a little complicated, but it's really no different than that. Which, remember then, difference of perfect squares. Now, the difference here, however, is that the stuff, it happens to be an expression. So in this case here, it's going to be tangent of x plus the cotangent of x plus the tangent of x minus the cotangent of x times, now the first thing, minus the second thing. And again, with the subtracting of an expression, please be careful. This is a place where people make mistakes, and you know what happens when people make mistakes. So this side over here is going to be simply, all the parentheses will drop because it's all adding. This side over here, the first one stays. The second one changes signs, because everybody gets subtracted here. Now when you simplify this, this side over here ends up coming up with 2 tangents of x, because those go away. Like over here, my tangents of x go away. And then this side over here becomes 2 cotangent of x. So that's going to become 4 times tangent x cotangent x. And you may have already see where this is going. Those are going to, since they're reciprocals, become 1. Answer is 4. This one down here is basically factoring. Think a squared, that shouldn't be there, plus 3a plus 2. So that's going to then become this effectively cotangent plus 2, cotangent plus 1. And obviously put the x's in because, well, it's easy to forget about your x. Well, sometimes it's not. Alrighty, let's review our 6 strategies for making our lives better, at least in trig identities. Remember, you need to know your identities. You need to know have them cold. If you don't have your reference, I know you all have your reference sheets out, but if you don't, do it now. Because if not, I mean, it's like wearing shoes to school. You just have to do it. You need to have your reference sheet out ready to rock and roll. Kevin, that's you. Start with the complicated side, rewrite in terms of sine and cosine, algebraic operations, do those. Remember your goals so that you don't get lost in the midst of it and do a whole bunch of work you don't need to do. And then last but not least, and I have an example of this today, if you happen to see a 1 plus sine x, it is going to be worth it to multiply by your conjugate. Okay? Because then you can get into the Pythagorean identities. So here. So she'll prove that. So you're going to write down the more, usually the side, if you have a choice of multiple terms or a single term, start with the side with multiple terms. That tends to be the more complicated. I'm doing air quotes. I know you can't see them, but I'm sure you could hear them. I would pause right here, and if you already haven't gotten the first step down, I would do it right now. What do you think your first step is? Take a swing. Check with your neighbor. That doesn't mean copy your neighbor. Turn to your neighbor and say, hey, I would do this. What about you? For those of you doing this along at home or up in Alaska by yourself, then obviously get on Skype. Find somebody. So you multiply all this stuff out. I'm going to come up with tangent A, cotangent A, which I think hopefully you guys are already thinking, hey, I bet you that is just 1. And your bet would be correct. Okay, so when you do this, this is going to turn into a 1. This is going to stay. Bell's going off in the back of your head. Hey, it's a 1 and a square term. Look at your Pythagorean identities. That's equaling secant squared. Big check mark. This was mostly algebra. Algebra 1 identity. You multiplied things out, you simplified things, and then bam, away you go. Okay? Next one's going to be a little bit more involved. The next one is probably, I would put it in the par of, this is going to be kind of in that focus plus range. And the reason why I'm saying that is if you look at this, what side's more complicated? Well, it's about the same. This is also going to be one of the ones where you sometimes end up needing to play both sides a little bit. Because like here on the first side, this is a perfect one for conjugates. So like here, if I've got 1 minus cosine x over 1 plus cosine x. Now the question is, where do you mess with the conjugates and where would you rather have, because I mean, they're both very close to sine squared. Okay, if it was 1 minus cosine squared, you would have sine squared. If the choice that I would do is always go for the denominator on that, is usually what's going to be the most useful. And the reason why I'm saying go for the denominator on that is take a look at the other side. If I'm playing around with cotangent x minus cosecant x, and this is why it's important to look at, see where you're going. Because sometimes, you know, you may think you're going one direction and you're actually, you know, supposed to be going in a totally different direction. If I multiply this out, I'm going to get cotangent squared x minus 2 cotangent x cosecant x plus cosecant squared x. Now, it's going to be tempting to say, oh, wow, look, cotangent squared x, cosecant squared x, if I get 1s, I can use Pythagoreans. And you can. The only problem here is this. Notice cotangent, I'm going to get my magic pen here. Cotangent and cosecant are not reciprocals of each other. And since they're not reciprocals of each other, they're not going to go anywhere. However, if we do rewrite these in terms of sine and cosine, remember that's one of our strategies too, I'm going to get cosine squared over sine squared minus, the 2 is going to stay on the top, cosine is still going to split out into cosine and sine, but now notice secant is going to become 1 over sine x, so now sine x times sine x is sine squared x, so I've already got a good start on my common denominator there, plus cosecant is going to be 1 over sine squared there, so we're really kind of all pulled together there. So in terms of that, notice I can rewrite all of this as sine squared x, and then over here I've got cosine squared x minus 2 cosine x plus 1. So since I've already got sine x or sine squared x in the bottom, that would make sense if I look over here on the other side. You know what? Let's do this. I'm going to put a big line down the middle, so that way we can keep these separate. So what will end up happening now over here on the left-hand side is that gives me the idea that when I do this, I'm going to multiply this bottom over here by the conjugate. So I get that difference of perfect squares. If I do it on the bottom, I need to do it on the top as well. But that's going to, when I multiply this out using the algebra, the bottom is now going to become 1 minus cosine squared x. Okay? And that's going to eventually turn into sine. On the top now, notice what I have here. I now have 1 minus cosine squared, or cosine x quantity squared. And if you're a puzzle person or if you're starting to get this, hopefully you can kind of see where this is going. You could probably make the case that say that you're done here. I'm going to kind of make one bridge step. So this coming down here The top is going to become, if I multiply that out, 1 minus 2 cosine x plus cosine squared x. And the bottom is going to become sine squared x. And notice it's just a rearrangement. From there, that's the exact same thing as I have here in the bottom. And then effectively, I mean, you're done, because notice if you just run this step backwards, and I'm not going to necessarily have you rewrite it backwards, but if I go from this step, and then if I break this fraction up into separate fractions, so I can put in this case cosine squared over sine squared minus 2 cosine squared x over sine squared, and this over here, that's going to break up into this, this, and this. And then from there, each of these will turn into each of those, which then allows me to factor it out into this, which means that big check mark Q, E, D. Now, some of you guys are probably saying, but Mr. Hayes, you said I can't do both sides of the equation at the same time. I said, no, you can't do the same things to the both sides of the equation at the same time. I said you could start and kind of work backwards. What I'm saying you can't do, and we're going to come back to this slide, don't worry. What I'm saying you can't do is, let's say if I had cosine squared x minus 1 is equal to, you know, sine squared x minus 2x or something like that. I could not do, oh, I'm going to add 2x to both sides, okay? You can't do stuff like that, okay? This, don't write it down. No, you can't do that. What you can do is what we did over on this side, where we played around with one side for a while, and then we played around with one side for a while, the other side for a while, and then we decided to connect the dots and saying, okay, we're at the same spot, now we can link it all up. It's just like that, you know, the trainway across the west example I did yesterday, analogy I said. One started in San Francisco, one started somewhere in the middle. They ended up in the middle of Utah. The two train rails, you know, the two trainways met in the middle, and then they attached the two, and then you can go the whole way. Okay, same idea. So the balance of the period is yours to work on some of these. Your assignment, I'm sure the sub is writing up on the board as we speak. If you're not done with stuff from yesterday, do that. But I really expect some good work out of you guys on this. This is, I think, 7 problems total, maybe 8. If you don't get it, jot it down, give yourself about a half a page of paper to work, and then go on to the next one, because obviously these have different things to do. Okay, they're set up differently, and while you may not get one right away, you might get another one, and they just kind of spark an interest on that. Okay, so none of this doing one and giving up stuff. I will see you tomorrow. Good luck. Treat each other well. Travel safe. And go.